Okay, turning the page, we're going to be looking at some problems where we have to use our log properties, mainly just one, and that is the power rule. So I'm going to go ahead and write that in here. Mainly the power rule. And this shows up because as I look at this problem on the left and the right, I have two different bases. And there's really no way of making them the same. And so it's like, okay, well, which inverse do I use? Do I use log base 7 or do I use log base 5? So what are some possibilities? Well, it says numerous, but there's actually infinite many ways of doing this. Now, in my day, we didn't have calculators, so there was only two ways for us to do this. And that was either base 10, log on our calculator, but we didn't have calculators, we had to use a table of numbers, or ln. So I'm going to show the four common ways. We're only going to do two of them together. But the four common ways is you say, well, I'm going to do log base 7. So that will be your first part, is to do your log. So log base 7 of 7 to the 2x minus 1 is equal to log base 7 of 5 raised to 3x. Remember, it has to be balanced. You have to do the exact same log on both sides. All right, over here, maybe instead of doing log base 7, I decided to do log base 5. And so it's going to be log base 5 of 2x minus 1. Actually, it's log base 5 of 7 raised to the 2x minus 1. And then log base 5 of 5 raised to the 3x. And the nice thing about that is they will get rid of one of your bases. So right here, those two bases will disappear. And on the second one, those two bases will disappear. And then you can kind of go with the flow after that. Now, I come from a time when we didn't have calculators to just plug stuff in, and we had to use tables that showed all the values. And so they couldn't make a table for every single base logarithm, so they only made tables for two. One of them was base 10, which is log on our calculator, and the other one was base e, which is ln on our calculator. All right, and so the same first step would apply. We take a logarithm of each side. In the previous two examples, we decided to take log base of one of the bases that was there. This time, we just take a generic log. So it looks like this. Log 7 raised to the 2x minus 1 is equal to log 5 3x. Or if I choose to use natural log, I go ln of 7 raised to the 2x minus 1 is equal to ln of 5 to the 3x. Now, even though ln is something that we have a calculator button for it and stuff, I won't say that this was a very common way of doing it, but it's doable. You could do it that way. All right, so I'm only going to do the first one and the second one, just so you can see an idea of what it's supposed to look like. Now, up here, back on this first one, I'm choosing to do log base 7 because the power for 7 is a binomial, and that's harder to do than a monomial. So that's why I'm choosing to do this one. So when I do that one, so the next thing you need to do is, if you have your bases cancel out, that's awesome. I just write that. But almost always the second step that you're going to have to do is the power rule. So the first step is to do a log. Pick a log to choose, do it. Second thing you're going to do is a power rule. Now, if your logs happen to cancel out a base, your power rule is super simple. But if it doesn't, then like here on the right hand side, then that power comes out as a multiplier, and we're left with log base 7 of 5. Now, on our calculator, we can do this. Our calculator doesn't do log base 7 of 5, but we know how to convert it. It's log 5 divided by log 7. So go ahead and do that right now. All right, so hopefully you got 0.8271. You may have rounded it to 8.27. That's okay. And what we're going to do now is to multiply that logarithm number that you just found to its multiplier 3, and that's going to give us an x value. And so I get 2.4813x. And over here I have 2x minus 1. And now we just solve it like a normal equation. I'm going to, yeah, it's not pretty, but I can do it. So I get negative 1 because I'm going to subtract 2x away. I get 0.4813x. And then now I'm going to do some quick dividing to solve for x. And I get negative 2.0779. Okay. And here's the great thing. All 4 of these answers will be identical. It's just different ways of doing it. So if I do it this way instead over here with log base 5, I should get that answer. If I do it with natural log, I should get that answer. And we're going to show you right now that using common log, LOG, on our calculator will also give us the same answer. Now the problem with LOG is I have all kinds of power rule I'm going to have to do. So we're going to do power rule. So go ahead and do that right now. Write down what you think that is. Go ahead and pause the video so you can write down what you think it is. Now this one's an easier example. There are harder examples, but we do have this binomial that is a multiplier now. So the only way to finish this problem is to get this logarithm distributed in there. So go ahead and, when we're not going to do a decimal yet, I want to show you what it looks like before you distribute. All right, so once I distribute, I get 2 times log 7x minus log 7, and over here I get 3 log 5x. So now at this point, I can go ahead and punch these numbers up into my calculator and get some decimals, and then finish the problem out using decimals. So let's go ahead and do that. Go ahead and pause the video. Take a few moments, get some decimal numbers for each of those parentheses and log 7, and then go from there. Okay, so there's my decimals. Hopefully yours match. If not, go back, make sure you have a 2 log 7 or 3 log 5. You're using the right logarithm, but those are the decimals. Now this is just a linear equation. I need to get rid of my x's and stuff like that. So go through the steps required to do that. Go ahead and pause the video and start doing your number crunching. Okay, so I start doing some number crunching, and once again I get negative 2.079, just like you did in the previous problem. No matter what logarithm you take, you will eventually get the exact same answer. It's all there is to it. All right, scrolling down here, the next thing, before you can do that natural log, your power needs to be isolated. So if you see anything next to your power, like a +7 or a -2 or whatever, in this case a times -4, you need to get rid of that first. So here we're going to divide -4. And so we're left with this. 1.25 divided by -4 is negative 0.3125. All right, then you'll do your log. Now in this case, it would make sense to go straight to the natural log. I mean, you could do LOG if you wanted to, but go straight to the natural log. And at that point, you should notice that you have an issue, and that is because when you try to take the logarithm of a negative number or 0, Nancy said that you can't do those. we get domain errors, and that is because you cannot have the logarithm of 0 or negative.